All right, we're here today with 7.3 molarity. So let's talk really quickly about what molarity is. So remember, molarity is moles over liters. So it's the number of moles in a liter. It's concentration. How many moles of solute are dissolved in the liters of solvent? And we represent that with the big M. I like to underline it just to make sure we know it's a big M molarity. Big M means molarity. Again, I like to underline it because little m means meters and we have mol for moles. There's a lot of M's in science. So it's helpful just to make sure we know for sure it's big M molarity. So moles over liters is big M molarity. So here we're trying to find the molarity of a sodium hydroxide solution. So two things we need. We need moles and we need liters. We have neither of those things. So I need to convert this to liters and I need to convert this to moles. So again, to get molarity, you need moles, you need liters, those two things. So let's get our 5 grams of sodium hydroxide to moles. We've done this before, 7.1. So I already looked up my molar mass of sodium hydroxide, and it's 39.997. I got that from the periodic table. I added up 1 sodium, 1 oxygen, and 1 hydrogen. And that gave me the molar mass of sodium hydroxide. So then I solve for X. I'm not going to show you that part just because we've already done this. I round to 3 sig figs because 5.00 grams has 3 sig figs. And I get 1.25 moles of sodium hydroxide. Okay, so that's the first thing we need. The second thing we need is this in liters. Remember, 1,000 milliliters equals 1 liter. So I divide by 1,000. That gives me 0.7500. Notice how you do 0, because it says 4 sig figs. So to get molarity, I do 1.25 moles over 0.7500 liters. Divide that out. And to 3 sig figs, I get a molarity of 0.167. And remember, my units on that are either moles for every liter, or I can write big M. Both are fine as far as units go. You can write moles for every liter or big M. That's how you calculate molarity. Again, the key is you need moles, you need liters. So this one down here is a little trickier. So I've got H2SO4, that is sulfuric acid. I'm going to just go ahead and calculate the molar mass of sulfuric acid because I know I'm going to need to go to grams, so I know I'm going to need that. So I do 2 hydrogens plus 1 sulfur plus 4 oxygens. And make sure, double check your math. And that gives me 98.071 grams for every mole. So we have 750 milliliters of solution. Again, I'm going to go ahead and change that to liters right away because, again, I know I'm going to need liters. And it's a 2.00 molar solution. Remember, when you see that big M, you can rewrite this as moles for every liter. That's what I would do. I would just rewrite it as moles for every liter. So if I wasn't sure where to go, I'm just going to take what I know. I know I've got this 2.00 moles for every 1 liter. I know I've got 0.7500 liters. And then that means this would be X moles. So I don't know how many moles I have. I haven't figured that out yet. But if I know the molarity and I know the volume, I can get the moles. So I'm going to go ahead and solve this. Again, even if you don't know where you're going yet, if you just do something, you can usually get there. But you have to start somewhere, right? To start plugging into the proportion what you know. So I've got 1.50 moles of sulfuric acid. I'm trying to get to grams of sulfuric acid. I know how to get from moles to grams because I have my molar mass. So I know I can take let me switch the color here, my 1.5 moles of H2SO4 over X grams equals, we figured out it was 98.0718, it looks like. Hard to read my own handwriting there. Grams for every 1 mole. And I just solve for X. And this right here is a really useful skill because a lot of times in chemistry, you have to make your own solutions. You'll be reading the directions and it'll say, hey, make a 2 molar solution. You're like, okay, make a 2 molar solution. How do I do that? Well, this is exactly how you would do it. You would figure out how much you want to make, so you need to know the volume. Usually, I make my solutions 500 milliliters or 1,000 milliliters, so I know how much I want to make. I'd figure out how many moles I needed, and then I'd convert my moles to grams. So once I've got it in grams, I can just head on down to the storeroom, get the solid, mass it out in the balance, and add it to my water, and bring my water up to the appropriate volume. So this is an incredibly practical math skill right here to be able to do this, because it's how you make solutions. You can't make solutions unless you can figure out how many grams of solute you need to dissolve in your solvent. And that's how you work with molarity.